Hello everyone, my name is Bao Cai from GCE Education Hub. Today, we'll be exploring the bonding and structure of ionic compounds. So, let's go! Okay, so firstly, the things you need to know is for compounds, there will be ionic compounds, covalent compounds, and metallic compounds. In this video, I'll be focusing on ionic compounds. So what are ionic compounds? Ionic compounds are compounds formed between a metal and a non-metal. Okay, so for example, sodium oxide. Sodium is a metal, oxide is a non-metal. Another example is magnesium chloride. Magnesium is a metal, chloride is a non-metal. So today we'll be talking about magnesium oxide, okay, which is another example of ionic compounds. So what does ionic compounds contain? Ionic compounds contain an ionic bond. And what is an ionic bond? It is a chemical bond formed by the transfer of electrons from the metal ion to the non-metal ion. So for example, let's look at the diagram below, the bonding between magnesium and oxygen. Okay, let's recall from the periodic table that magnesium atom has 12 electrons. This means it has an electronic configuration of 282. 282 gives you 12. So to achieve noble gas configuration, it has to lose the extra 2 electrons. Okay, so how does it lose these 2 electrons? It will depend on the partner it is combining with. So in this case, magnesium is combining with oxygen. Okay, and if you recall from the periodic table, oxygen has 8 electrons, which means its electronic configuration is 2,6. And to achieve noble gas configuration, it has to gain 2 electrons to become 2,8. Okay, so since magnesium need to lose 2 electrons and oxygen need to gain 2 electrons, they are perfect for each other. Which means in this case, the magnesium will transfer 2 electrons to oxygen. And since magnesium has lost 2 electrons, its charge will be 2+. And since oxygen has gained 2 electrons, the overall charge will be 2- for oxygen. Okay, so the ionic bonds is the attraction, the chemical bond, okay, formed after this transfer of electrons. Okay, and in this case, we'll be talking about giant lattice structure, which is the structure of ionic compounds. And if you see on the picture on the right, the Mg2+ ions is depicted as the blue ions, and the oxygen is depicted by the green ions. Okay, and if you see the overall picture, it looks like a lattice structure. Okay, it looks like a box and all, so we call it a giant lattice structure. And because of this giant lattice structure, the magnesium oxide has high melting and boiling point. Okay, this means that large amount of energy is needed to overcome the strong electrostatic forces of attraction between the oppositely charged ions. Okay, in this case, the 2 oppositely charged ions are the Mg2+ ions and the O2- ions. Okay, so they need to break the bonds. Okay, and because the one is plus, one is minus, there will be this spark, okay, this electrostatic forces of attraction. Okay, so this is the high melting and boiling point of giant lattice structure. Let's talk about the electrical conductivity of magnesium oxide. Okay, in a solid state, as you can see from the picture on the left, the ions are stuck together. Okay, but when they are in liquid form, the ions are separated. Okay, so in terms of electrical conductivity, in solid state, magnesium oxide cannot conduct electricity, okay, because there are no free mobile ions. They are all stuck together. Okay, they are fixed in position in a giant lattice structure. However, if the magnesium oxide is in liquid form, okay, the Mg2+ and the O2- ions are free to move. They dissociate. Okay, they dissociate to form free mobile ions, which can conduct electricity. Okay, so in conclusion, magnesium oxide, which is an ionic compound, has high melting and boiling point due to the strong electrostatic forces of attraction. Okay, and in solid state, it cannot conduct electricity. Okay, but in liquid state, it can conduct electricity. So please take note. So this is what ionic compounds are all about. If you find the content we are sharing useful, remember to like and subscribe. See you soon. Bye bye.